My name is Carlos Miguins and I work as head of pre-sales at HeliCloud. What I actually do is service development with a serious dose of evangelizing. After having majored in computer science, I've spent the last 30 years working at all levels of private and public sector organizations, and I've been surfing the technology wave since the beginning, starting with the earliest days of relational database and ending up with the seismic shift that is the cloud. I'm a self-confessed geek who still likes to get his hands dirty. But enough about me. Over the course of the next 30 minutes or so, we'll be looking at how HeliCloud delivers compliance in a continuous way for our managed service clients using AWS technology. We'll look at some of the issues we see with companies and systems as we onboard them to managed services. Then we'll look at various security standards, AWS architectures, methods and processes that we use for our customers. This is a continually developing and changing area, so I'm hoping that at the end you'll be encouraged to explore further and perhaps raise questions about your own security posture. I'll start with what we see as the major issue with compliance management, well illustrated by this meme. Whatever data security policies and tools you have in place, there is always the element of human error to be considered. And while security is primarily aimed at protecting you from attackers, the goal of compliance is to maintain the baseline level of security throughout all internal changes. And my apologies to you, dear listener, if you are called Dave. But why does compliance management fail? There are a range of reasons for this, and typically it is a combination of a number of these. Audit-based compliance is one problem we see, where the focus is on the audit rather than on the compliance. We care about compliance just before or just after the audit, and we typically have a push a few months before the audit, and then another push after the audit. But soon after, we lapse back to previous ways. If we focus on compliance itself, then the audits become easy. People are another area. People are amazing things, but they need training, and of course we train our people on security. I've been on this training myself. We test people by sending them fake phishing emails to see if they will bite, and then remediate with training if necessary. But we have to realize that security isn't people's first priority, or job, unless of course they work in security. There is a book called The Phoenix Project, which I can hardly recommend as a good read for a predominantly technological book. In there, you will find a great running story about the interplay between security, development, and operations. The constant change and tight deadlines do impact the implementation of compliance. And interestingly, in the book, the Chief Information Officer introduces a security fix onto a number of servers without control, and in so doing broke the payroll run for the month, which took quite a while to resolve. He was doing something manually which should have been done in a tested and automated fashion, and this is something we frequently see. Humans are a weak link. However, there are scant automations for assessing compliance and remediating. So what does continuous compliance look like? We view compliance as a circle with 5 main principles. First, you need to understand the compliance standards you have to adhere to and ensure that you keep up to date. Then, you also have to set your security posture, updating your assessment criteria and making sure that it's adapted to your infrastructure. The logs and assessments need to be aggregated and fed to a centralized security incident and event management system, or SIEM, so you have full visibility and analytical capabilities. Of course, you may have to build your SIEM in the first place, and this SIEM will underpin the Security Operations Center or SOC function in your organization. Many organizations find this a challenge because of skills and resources, and that's where a company like HeliCloud comes in, where we can take this burden away from you. The SIEM offers a centralized way to give full visibility and analytical capabilities and handle security incidents and events in an autonomous way. Nevertheless, It's still just a tool, and when incidents are raised, it still needs a person involved to take decisions. But as we see later, there are some automated actions we may be able to take. Since the first step for continuous compliance is understanding the standard, let's look at these a little bit more. What I like most about standards is that there are so many of them. Some you need to choose for yourself. Some may be mandated for you through legislation, regulatory authorities, or industry bodies. This is the first area where running your infrastructure on AWS is a big plus. AWS has a shared responsibility, security, and compliance model, where the security of the cloud is AWS's responsibility and security in the cloud is your responsibility. This shared model helps relieve your operational burden as AWS operates, manages, and controls the components from the host operating system and virtualization layer down to the physical security of the data centers where the services actually operate. This means that AWS is already compliant with the standards that you also need to be compliant with, for example, ISO 27001. But more than this, AWS also offers you a range of tools and resources to address security in your architecture, starting with a well-architected framework. We've covered the well-architected framework in previous events, and this has a specific security pillar with its own white paper and resources helping you to establish a good security posture in the cloud. More recently, AWS have adopted the CIS benchmark into their Security Hub product, and we integrate this into our SIEM offering. The remaining standards on show here are broken down into two sorts: general security benchmarks and industry-specific guidelines and standards, some of which are mandated by law, and you should know which are applicable to you. For instance, operating in the EU, we are all bound by GDPR. If you are processing credit card data, you need to adhere to PCI DSS. So let's use PCI as an example and look at PCI compliant architecture in AWS. AWS has provided a number of very useful materials, including reference architectures that correspond to specific compliance standards. There's no rocket science about this, it's a lot of common sense and standard security best practice that you should adopt even when running on-premise. This is a reference architecture from AWS for a PCI compliant system. PCI is Payment Card Industry's standard for systems which process credit card payments. This architecture supports the well-architected framework best practices for high availability and security through a range of characteristics including a multi-AZ architecture intended for high availability, isolation of instances between private and public subnets, security groups limiting access to only the necessary services, and network access control lists to filter traffic into subnets as an additional layer of network security. A secured Bastion host instance to facilitate restricted login for system administrator actions is also included, and S3 buckets with security features enabled for logging, archive, and application data. And the list continues, but you get the idea. Furthermore, following best practice, this architecture would be deployed into a well-architected landing zone, something which is vital to ensure compliance, but is outside the scope of this session. Here we see the PCI rules which the architecture addresses and implements. You'll see a number of items underlined in red here, which we'll see again later. Let's look at a different reference architecture. This reference architecture from AWS is for a HIPAA-compliant system. HIPAA is a security framework for the health sector and is US-centric, but I decided to use this one as it embodies some of the same examples as the PCI reference architecture. In fact, if you're eagle-eyed and indeed observant, you will see that this architecture is actually exactly the same. Let's develop this theme by looking at GDPR, a requirement we all have when operating in the EU. Again, AWS usefully provides a white paper which is very useful as a start for complying with GDPR on AWS. If we look at the rules themselves, you'll start to see the pattern of repetition occurring, harking back to the PCI rules we looked at earlier. Monitoring and logging, encrypting data at rest and in transit, and data access controls. Let's look at one more example. This paper is older but demonstrates another important aspect of security standards. They change slowly over time. Although security threats are evolving quickly, standards deal more with slower moving processes and practices. The rules for Cyber Essentials Plus again hark back to the PCI rules and GDPR. And once again, the message is that many of the standards and benchmarks have similarities. Having understood which benchmarks and standards are applicable to you, you next need to update the assessment criteria, or define them if this is your first time around the circle. But before we do that, let's look at the tools we'll use to embed those rules. Our goal is obviously to automate as much as possible, and AWS has some good tools to allow us to do exactly that. There are a range of powerful security tools at your disposal, from firewalls and endpoint protection to vulnerability and compliance scanners. But this means switching back and forth between these tools to deal with hundreds and sometimes thousands of security alerts every day. Security Hub gives a comprehensive view of high-priority security alerts and security posture across all AWS accounts. AWS Security Hub continuously monitors your environment using automated security checks based on the AWS best practices and industry standards that you've chosen to follow. Security Hub provides some visualization, but really it's ideal for outputting events in a normalized form into tools that can be used for investigation or response. For example, you can take action on these security findings by investigating them in Amazon Detective, or by using Amazon CloudWatch event rules to send the findings to other systems. For instance, we integrate our security information and event management system with Security Hub in exactly this way. We also use this mechanism to run custom remediation playbooks, which we'll see later on. Suppose that we've decided that we're going to comply with PCI DSS and the CIS Foundation benchmark. Our first step is to create the assessment criteria inside AWS Security Hub. Fortunately for us, both of these are pre-canned and easy to set up. However, there are still some tweaks that will be needed. For instance, some foundational controls could be disabled on a regional level as they are global in scope. But what I'm showing here is a very simplified model of the setup. We've set up our rules for assessment and they are now running. What next? Ideally, you'll want a seam to aggregate, store the data, and allow visualization of the security data over time. At the risk of scaring you, I'm going to share the architecture of our seam. Somewhere in there, you will find AWS Security Hub. But there are a plethora of logs which we need to capture, which Security Hub does not cover. For instance, logs from elastic load balancing events. We may also be using services such as API Gateway, which don't patch directly into Security Hub. But what I want you to take away is that the seam is the central point for all your security information in order to manage incidents and events. Perhaps one day Security Hub will perform this task, but it's not there yet. Let's focus now on what we can do with this wonderful information. At HeliCloud, we are mad keen on automation. You can see this by our partnership with HashiCorp and our extensive use of Terraform to implement infrastructure as code. This also extends to dealing with security events and incidents where possible. So I'd like to share a couple of playbooks with you that show how we do this for our managed services clients. What we are effectively talking about is automated remediation, or Shoot first, ask questions later. There are a group of security exceptions which there should be no discussion about that should be immediately remediated, with an investigation later about how and why they happened. Here's an example from the CIS AWS Foundations benchmark. We never want to allow global ingress on SSH port 22. How's this achieved? First, that particular change or addition to the system would be picked up through the AWS config service. This sends the finding to Security Hub. This would have been set up with a custom action to happen on this occurrence. Custom actions have the ability to do a number of things. In this case, however, we are triggering a CloudWatch event, which has a rule that triggers a Lambda function. This Lambda function is a piece of code which runs, defined by you or us, which carries out the remediation on the system, in this case deleting the security group. Simultaneously, we will also create an incident in our service manager at Jira, which can be investigated by the security team. The Lambda function is a serverless function. This whole process shows a single action, but this could be applied to a range of other security and compliance controls. For example, ensuring access keys are rotated every 90 days, disabling accounts without MFA, ensuring that S3 buckets are not publicly accessible, and deleting resources without tags. We'll come back to resources without tags later on. Here is our second playbook example. In this case, we are looking at implementing the CIS control for vulnerability. Utilizing guard duty, we've picked up an infected AWS instance. This might be a virus or malware, for example. It creates a report and files it with Security Hub. As before, Security Hub raises an AWS CloudWatch event, which in this case we're not showing. This event kickstarts a Lambda chain. First, we need to log an incident. Again, we're using Jira for service management. But now the interesting part starts. The first remediation Lambda isolates the instance from the network so that it's no longer accessible. Then we take a memory dump and a disk dump. Both of these go to an S3 evidence repository for use later. And we do this because the next step is to terminate the instance. Now that the instance is gone, we still have all the information we need to be able to conduct a forensic examination. It's important to point out that you might not want this to be an automated remediation. Unless your architecture is properly designed, you may find that this terminates your complete application. And so currently we only have one customer where we implement this automated remediation. This final example is a great example that brings us to the end of the cycle, where we need to capture changes to our infrastructure and processes. This integrates well when you're using infrastructure as code, as shown here. The seam detects an issue, and it can automatically initiate a build request. Moving security to the left has become a coined phrase, meant to describe the process of embedding security at the beginning of software and infrastructure lifecycle. For example, we spoke before of a check being that all running assets should have at least one tag associated with them. In this model then, any assets that don't have a tag could be terminated automatically through a Lambda function, for example. But what if we could move that control earlier in the cycle, that is to the left, and stop the resource being created in the first place? Once again, our partnership with HashiCorp comes into play. By embedding Terraform Sentinel as part of our DevSecOps process through a CI/CD pipeline, we can start to be proactive about controls rather than reactive, and be able to deliver security best practices baked into our systems, or security by design. The code that you see here specifically catches any resource that is being created without tags. You'll have to take my word for it. You could see this extending to many other controls, for example stopping any S3 buckets being created that are publicly accessible. Of course, this approach requires that you use infrastructure as code and have immutable infrastructure, where people never directly create servers or services. We have reached the end, where the end is the beginning, on our continuous compliance circle. We've spoken at some length about how we provide this level of continuous compliance for our customers, but you too can avail yourselves of this service through our managed security and compliance offering, which includes a fully managed SIEM. You don't need any specialized software or software as a service. Our skilled cloud security engineers build a SIEM right into your AWS infrastructure. This means that all your data stays within your AWS account and region, avoiding any problems of data residency. The service can be up and running in a matter of weeks, and so you get fast adoption. And because the service is cloud native, we've been able to create automation for incident response and keep the service at the cutting edge to address evolving threats. We keep you informed through regular reporting, and since we build and run the service, you get 24/7 by 365 coverage without employing any extra staff. This removes the hard work from security, freeing you up to concentrate on your core business. AWS and the API nature of access to cloud services facilitate the highest level of automation possible in IT today. And at HeliCloud, we take full advantage of automation to ensure that we keep your systems secure through automated remediation. If you take away only one thing from this session, it should be to automate security as much as possible and keep Dave away from your infrastructure.